Good evening, friends. Study with the Pala Engineering and Journal Geology Parvin book. Our chapters 8 physiographic features global effect divergent boundaries का अब global effect क्या है. The best way to understand the mechanism of plate movement is through the example of effect produced by these drift in different parts of the earth during the recent past. The North America's plate is believed to be drifting away in a westward directions with respect to Eurasian plate, which is moving in an easterly direction. It is therefore a classic example of diverging plate boundaries. It is believed that this divergent movement started some 200 million years ago and resulted pourings out of emergence of huge volumes of molten materials from below that has all built up the middle Atlantic region, which forms a major part of the sub-oceanic region. The encircling the global from the Arctic Ocean to South Africa, this type of a process is sometimes also referred as the sea floor spreading. This particular case of divergence is believed to be taking place at a rate of 2.5 centimeter per year or 25 किलोमीटर पर मिलियन ईयर्स. इट मे बी अगर आपको मेरी स्पीड ज़्यादा लग रही हो तो आप इसको जब यूट्यूब पे चलाते हैं तो ऑप्शन देते हैं कि आपकी कैसी नॉर्मल स्पीड रखनी है, कैसी उसके हिसाब से सेट कर लीजिएगा. अगर ज़्यादा धीमी लग रही है तो आप फास्ट कर लीजिएगा. ठीक है. It may be interesting to note that the volcanic country Iceland is an island located on the mid-Atlantic region and has received much importance as a natural laboratory of recording movement connected to the divergent plate movement during last 50 years. Many cracks have been recorded appearing and others widening around Krafla volcanoes in northern Iceland. The displacement of about 7 meters during the period of 1975 to 1984 in this regions are often cited as examples of divergence. Some protagonists of plate tectonics have postulated the development of new spreading centers under the African plate along the East African rift zone. According to them, if such a spreading happens continue, then the Earth will have its next major ocean along the vast Africa. It would take, of course, a geological time, millions of years to happen. Convergent boundaries, the other significant movement of lithospheric plate is of a convergent type in which two adjoining plates comes close to each others and from opposite directions the end collides. Three possibilities have been suggested and supported by observations. First, of the two converging plate, one is a continental plate and made up primarily of lighter and brittle rocks, and the other is an oceanic plate made up of harder and denser materials. Second, both the converging plate are primarily oceanic plate of a heavier and denser type. Third, both the converging plates are primarily of continental type made of ridge and brittle rock along the boundaries, and convergence of such combinations of plate leads to entirely different results, which are verified by live examples on a global scale. Case 1, when an oceanic plate is pushed means दिए धक्का दे रहे हैं आप किसी को, pushed onto a continental plate and being heavier, harder and denser, the oceanic plate goes or subduct under the continental plate. So the movement is of the a continuous smoothly sinking type. The plate subducting deep into the interiors of the earth for as much depth as the mutual dimensions of the converging plate allows. The net result of this type of subduction is just sorry is just a reserve in geological terms. Then that of diverging boundaries. Subductions involves destructions of the crust. In fact, it results into long, narrow and deeper trenches along the subducting boundaries. The Peru's Chile's trench develops off the South America's and coastline is described as a typical example of subductions. What happens to the overriding continental plate? It is naturally is lifted up at the boundaries and result in mountains range and belts. The South America continental plate and supporting the high range of Andes mountains is considered a proof enough of this particular case. Case 2, when both the converging plate are of oceanic types, that is, they are located at the ocean floor at a great depth. Subduction remains the principal movement, and the result is again primarily development of a trench, and rather deeper and the deepest trench, the boundary of subducting plate may subduct for quite deep into the asthenosphere. And so the Challenger Deep, the deepest trench record, plunge almost 11,000 meters down into the earth interior. It is located at the southern subductions end of the marine trench, caused by convergence of a Pacific plate or oceanic type. Case 3, in thirds type of convergence, where both the plates are made up of continental rocks, there is no subductions as such, but collisions of almost head-on type. Such collidings often result in buckling, foldings, fracturing, jointings, and displacement, faulting at different locations, depending on the natures of rock. Example, if they are soft, brittle, and flexible in nature respectively. Bucklings also result in creating havings up at the plate boundaries. The origin and evolution is termed as of a higher height of the Himalaya is considered as one of the best examples supporting the collision of two continental plate, the Indian plate and the Eurasian plate. The process is believed to have started more than 50 million years ago, with the Eurasian plate advancing southwards towards Indian plate that was itself drifting northward. The slow continuous convergence of these two large continental plates continued over millions of years and resulted in pushing up the Himalayan belt and the intervening Tibetan plates to their present height, mostly during the last 10 million years. The Himalayan standings as the tallest and the youngest of the continental mountains range of the world are cited as the most dramatic example by the proponent of the plate tectonics. Their growth is believed to be a continuous process even at present. Hence, the Himalayan systems are considered tectonically very active and locations of many major earthquakes of the past and of many potential earthquakes of for future as well. Thank you.